Thank you for giving me this opportunity to present the updates about UFS-based coupled gaps. Yeah, I want to give thanks to all the colleagues at EMC from different divisions, coupled model division, and dynamics and physics division. A lot of contributions from the co-workers. I also want to acknowledge all the UFS community model developers. Here's a very long list because this is UFS-based models, but contributions from all of these developers, not our own. So here's the outline of my talk. First, I'll give you a very brief introduction about GAPS version 13. This is the next version GAPS, and then I'll bring some results from the UFS-based coupled group ensemble systems. We have 5 ensemble prototypes targeting the next version GAPS version 13, and some very brief results about the first 3 ensemble prototypes, and I think the focus will be the last 2 prototypes, EP4 and EP5, and we have full set EP4, but only mini set EP5. And I lastly give you the current GAPS version 13 status, and also what's the next we are going to do. So here I'll show for the next model upgrade for global models in NOAA from the deterministic model GFS version 17 to GAPS version 13 to seasonal forecast system version 1. It will be all coupled, fully coupled model, like this different components, two-way coupling, aerosol, ocean, ice, wave, atmosphere, land. So this is the difference between the current operational uncoupled GAPS and the next version GAPS version 13 is fully coupling. So there's a lot of differences, a lot of updates, but I think the major upgrade will be fully coupling ocean and ice model, and also wave and aerosol from one-way coupling in GAPS version 12 to two-way coupling in version 13. Also for the aerosol only have one member one-way coupling in GAPS version 12, but for next version it's going to be all the ensemble members and two-way coupling. So here's the timeline of this UFS coupled model prototypes. We have developed the 5, as I said, we have 5 ensemble prototypes targeting the next version GAPS. If you are familiar with the UFS coupled model prototype, we have 8 UFS coupled prototypes, and also have 3 high-resolution prototypes for UFS coupled model. And for ensemble prototypes are based on this UFS coupled model prototype. Here is some math for example, like EP1. This is the first ensemble prototype based on coupled model prototype 5. And EP2 is based on 7, EP3 based on 8, EP4 based on SR1, EP5 based on SR3. But we don't have ensemble prototype based on P6 and SR2 because usually we start ensemble prototype development. We need to run model, run experiments, and we need to also do the evaluation. It usually takes 8 to 11 months to complete on just one ensemble prototype. And from P5 to P6 takes only 6 months. So we haven't finished the EP1 before this P6 is available. And same thing for this EP4, we haven't finished EP4 evaluation before SR2 is available. So we just wait for the next prototype to build our ensemble prototype. And here I'm going to introduce experiment design of all these ensemble prototypes. So we are going to use the GAPS version 12 as a reference because we have GAPS version 12 reforecast 30 years, and we have 10 participant members and 1 control member. This is going to be the reference. And so we have our ensemble prototypes also include 10 participant members and also 1 control member. We didn't use 31 members because of the computation resources. It's gonna ensemble gonna cost a lot of resources. So we just run 11 members and to compare with GAPS version 12 reforecast. And the bad thing is because we don't run 31 members, we cannot compare with the latest recent years, like starting from 2020. The most recent years, we don't have the comparison because starting from 2020, GAPS version 12 have 31 members. So, but we can still see that the 11 members to compare. Yeah, I'll show later. So basically, the run period, all the ensemble program will run 2-year experiments from October 2017 to September 2019. And for the latest 2 ensemble prototypes, EP5, EP4, and 5, we run another year. The latest, not the latest, but the recent year, October 2020 to 2021, September. And usually before we start a full set, like 2 years experiments, we run a mini set, just make sure everything is correct, and it's a very quick check for the ensemble prototype. So for mini set, we run only 16 cases, including 8 winter and 8 summer cases in 2018. This is mini set. And for initial conditions, we use, for analysis, we atmosphere use CFS analysis from V15 or V16. And for ocean, initial condition analysis, we use CFSR, temperature and salinity. And ORAS5 for, we have 5 different ensemble prototypes. For the initial conditions are different for different ensemble, like EP1 uses ocean analysis, and EP2 to EP5, so like ORAS5. And ice analysis use CBCI ice analysis, and the wave here, and also same thing for initial perturbations. For different ensemble prototypes, we have different configurations, and especially for EP5, the latest one we are using GAPS version 13 replay initial conditions. This data set will be the initial condition for GAPS version 13 reforecast. So we're gonna test this in our the last prototypes. And yeah, it's a lot of information. I have this link. You can, I think after meeting, you can get this slide, and you can have this link. You can see all the information about ensemble prototypes and experiments. You can see some details. So here we're gonna show some results. This is for EP1 and EP1 to EP3, 3 ensemble prototypes. And the reference GAPS version 12. This shows the scale of 500 millibar 0% height. On the left is northern hemisphere. On the right is southern hemisphere. You see all these EP1 from EP1 to EP3 CRPS score here. It shows better compared with GAPS version 12 is black here overall. And also for the southern hemisphere, same thing. But after, I think it's only up to 2 weeks. After 2 weeks, starting from week 3, it's kind of mixed, like especially for southern hemisphere, it's mixed. And for northern hemisphere, still good. But I need to mention there's no significant test for this one. But later I will show some significant for the results. Right now, basically, we can only see it looks good. This is biases for 500 millibar height. You see different red EP1, green EP2, and blue EP3. So we can see here is northern hemisphere 500 millibar height. We see the warm biases in EP1 and EP2, the green and the red. the EP3 is pretty close to gaps within 12 current original biases. And for the isotropic is pretty similar for all the experiments from EP1 to EP3 compared to gaps within 12. And in southern hemisphere, you see the EP3 is better because it kind of reduced the warm biases because all EP1, EP2, and also gaps within 12 have warm biases. And the EP3 reduced the warm bias here. See. And this here shows the ensemble RMSEM spread. This is only in the tropics, 250 millibar upper level zonal winds. You see, I want to show here is so you see the different ensemble property like EP1, the spread and the error is good. It's really safe. It's good. It's pretty matched. But if you see the green S line EP2 spread, it's kind of under dispersive. And if we go to EP3, the blue dash line is a little bit over dispersive. So I'm not sure here is from the ensemble spread changes following the updates of ensemble properties, because a lot of updates from one prototype to another. The physics update impact the tendency. It's going to eventually impact SPPT contribution because this spread is mainly determined by the stochastic physics and SPPT in the tropics. So this is an indication of changes of the physical tendency from one prototype to another. So I'm going to show some results from EP4. And before I show the results of, as I showed in previous figure, a lot of updates from one prototype to another. You will see the physical tendency, it's a lot of changes. You see here, this is one sample. This is one case from EP4. And this is the 2017 October 4th. It's about 10-day forecast. And EP3 this is the physical tendency. And also for different physical schemes like macrophysics, PBL, deep convection. And the black line here is the total physical tendency. It's a vertical profile, it's a height, and this is the value. You see the EP3, and it's solid, and the dashed line is EP4. So you see the total tendency, physical tendency is totally different. From EP3 to EP4 increase a lot in the middle level. See from here to here. And we can also see from this figure, the contribution is mainly from the macrophysics. See the blue lines, macrophysics, and the red line, the deep convection. So it's two physical scheme, the major contributions to this increase of this total tendency. And you know, SPPT is mainly determined by this total tendency, physical tendency, it's a tendency perturbation. So, and also, you need notice, you can see here, the PBL physical tendency is pretty large. And yet from EP3 to EP4 also increased. And at very early stage of EP4 testing, we see a lot of crash, model crash, because of this stability issue. So we add this PBL taper in EP4. Basically, just reduce the perturbation at the lowest level, like the lowest 7 levels, to reduce the perturbation amplitude. So that in that way, we can stabilize the model and can finish the EP4. And this here shows the SPPT, the reduction. Actually, this is the 30% off is compared with current gaps within 12. And as EP3 is 25% off. And I saw here, EP3 is 25% off, and EP4, because we have increase, we see the increase of physical tendency. So we further reduce the SPPT from 25% off to 30% off. Here shows some results from EP4, and this is a comparison between EP3 and EP4. It's also 500 millibar geopolitical height, CRPS, and pattern correlation. You see, they're pretty close to each other. So if you see the CRPS and PAC is pretty similar between EP3 and EP4. And we see here for PAC a little bit degradation you see from in the EP4 compared with EP3. How about the model biases? This is the 850 bar temperature bias, EP3 compared with EP4. You see the black is EP3 and the red is EP4. We see this is the northern hemisphere, tropics, and the southern hemisphere on the right. You see for all this, you can see generally overall EP4 is colder compared with EP3. You see a little bit more cold biases compared with EP3, like a few 0.2 degrees, something like that. And also northern hemisphere and tropics, it's not clear in the southern hemisphere, but pretty clear in the tropics and the northern hemisphere. And this is MGO evaluation, so RMS, MGO, RMSE, and spread. It's EP4 is 2 years experiment. And again, the black is gap 12, so you see the spread is pretty large. And the red is EP3. See also, and this is RMSE, kind of over dispersive. And the green is EP4. We see the spread, error spread relationship is pretty good in EP4 because the spread and error is pretty close. But we also see the error is a little bit increased compared with EP3. But if you see the MGO scale in terms of RM1 and RMM2, both EP3 and EP4 is better compared with gap 12. Kind of increase the prediction scale like 5 days around. And EP4, EP3 is pretty close, but you see here a little bit degradation compared with EP3. If you see this scale. As it corners precipitation bias for is only week 1 average. It's a gap 12 and it's EP4. Here's the difference. You see the blue color means reduce. It's a kind of purple color means bias has been reduced, and this is the crosshatch. So the significance is 95%. So overall, it's bias has been reduced from gap 12 to EP4. So this is good. And this shows the hurricane evaluation. It's only so 1 year, 2020 to 2021. It's a track error. This is blue is version 12, gap 12, and the red is EP4. And we see the track error. We see for all the forecast hours, EP4 is better than gap version 12. It's basically reduced the track error. But if you see the intensity error, it's EP4 is worse compared with gap version 12. See for different forecast hour, the intensity error has increased almost for all the forecast hours. And actually, this is the results very similar. Even in EP3, it's very similar, and EP4 pretty similar. But we don't have results for EP5 right now, because only have mini set run. So here's a wave evaluation. Because we have very good wave model performance in gap 12, and we only starting from EP4, we start the evaluation for waves, and we don't have wave evaluation for previous 3 prototypes. And we see here, we noticed it's EP4, the high wave prediction is worse compared with gap 12. Here's gap 12, it's EP4. You see the QQ plus is high waves. It's not as good as gap 12. So the wave team has some tuning the different parameters, like here so here is no current, so it mainly tune this Baymax parameter. So for the original, it's kind of 1.3 something, and we tune the different parameter. Basically, we found this is 1.5 shows the best results. As you see here, it's comparable with capsulosin 12, and it's 1.45. So we tune this Betamax 1.5 as our final configuration for it. One of the reasons is in capsulosin 12, the wave coupling is only one-way coupling. And right now I have feedback from waves. So that's probably the cause of this kind of high wave prediction is not as good as this capsulosin 12 because I have two-way coupling. So we tune this parameter and finalize at this value. So starting from EP4, after we finish the EP4 experiment, actually we have decision we'll include aerosol, two-way aerosol coupling in the next GAPS model. So starting from EP4, we have included aerosol experiments. Like for EP4, we have run another 2 years full set, including the prognostic aerosol and also with observed emission. This is one experiment. I'll show some results in the next slide. And for EP5, this is RC based. We only have finished mini set. And we have mini set EP5D. This is the aerosol. We include two-way coupling aerosol, and we have introduced this blending emission because it's for the original forecast. We don't have this fire emission information. For forecast 35-day or 48-day forecast, we don't have emission information. So there's just the aerosol team developing a scheme. Just use observed emission for the first 6 days, and after that, is blending the observed emission with the climatology emission, kind of a blending scheme. So we use this scheme for EP5D and also EP5R2. The EP5R2 is different from EP5D in terms of initial conditions. From EP5R2, we are going to use replay initial conditions. Actually, it's generated by using the UFS-based model, replay the ERA file for atmosphere and ORS file for oceanize. So different. For EP5D, only still use the previous GFS initial condition. So it's a difference. Here shows the results from EP4B and EP4. We see overall the green is significantly better and the red is significantly worse. So overall is comparable, but we do see some biases, degradation for the upper level. We see the highs and also temperature here. Some degradation here after including the aerosol. Here's a weekly average, the AC score for three different experiments. The capsulosin 12, EP4, and EP4B, including aerosol. So all the week 1 to week 2, weeks 3, 4, all is better. Even we include the aerosol, little impact. But we do see in the southern hemisphere after including the aerosol, see week 3 and week 4. Previously, EP4 without aerosol is kind of worse, but not significant. After including aerosol, it's significantly worse. And here we're going to show EP5 mini-set results. It's only be aware, so mini-set only includes 16 cases, in 8 summer and 8 winter cases. So this 500 millibar AC score for winter time, and the capsulosin 12 in black, and EP4 in red, EP5D in green, and EP5R1 in blue here. You see overall is all the coupled gaps is better than the capsulosin 12. But if you see the error bar is not significant in the northern hemisphere. And in the southern hemisphere, we do see up to about 10-day forecast. The EP5R2 is significantly better compared with capsulosin 12. But after that, it's little work, but not significant. And this is summer. Summer is not, basically all the experiments are pretty similar. You see the difference here. mixed together, and also for scientific fair, is sometimes it's better for the early forecast study for EP5R2, but after that it's kind of mixed. So this is aerosol. It's AOD bias in EP5R2. For winter, the top is for winter, and the summer is at the bottom. It's week 1, the middle is week 2, and week 3, week 4 on the right. And overall, we see all this winter, summer, and all different weeks forecast. Overall, it's under predict the AOD. AOD. You see, but right now we don't have this reference because gaps within 12, including the runway couplings, only available after 2020, September 2020. So we don't have a reference for this. They're going to run 2020 case for in the full set run. So we're going to have the reference for this. But basically, we see the under prediction of AOD in the is a couple is EP5R2. And some scorecard for EP5R2 again is it is EP5R2 compared with the capsule in 12. It's RMSE is score, and this is got an RMSE. This is winter and the summer for different season. We see overall basically it's favorable for the EP5R2 compared with capsule in 12. It's especially for over 700, but still see some mixed results. See some red here. This is bias for winter and summer, winter on the left and summer on the right. For bias, we also see some degradation both summer and winter, especially for see the winter times, the lower level, 1,000 millibar here in temperature, and also summer times the temperature at 1,000 millibar also here. Some mixed results we so far we found in this mini set. Okay, very quick summary. We have 5 ensemble prototypes have been finished following the development of UFS coupled model. So overall, the coupled model, ensemble model outperformed the current original capsule in 12. But we do see some degradation for some metrics. And the latest ensemble prototype, this is EP5R2 is running for the full set right now. We just started a few days ago, and we only have some results from the mini set. We have finished 6 mini set, and we are waiting for the evaluation for the full set after we finish that. So the full set will be expected to be finished by early July. And the plan is we're going to finish the EP5R2 full set run by July 1st. And the evaluation period for EP5R2 will start from July 1st to the end of July. And we are going to launch the gaps within certain reforecasting sometime in August if we have the workflow for ensemble is ready. Because right now we are using kind of experiment workflow temporary for the experiments, and not for the official gaps within certain reforecast. And also, it depends on the results. If the results from EP5R2 is satisfactory to all the stakeholders and agencies. Yeah, I think that's all. I'm happy to take any questions.
Thank you very much, Bing. Yeah, we have several questions on the discussion document. So
okay.
Let's start with the second one. What defines a complete EP and just compute time to run the date?
Basically, EP means ensemble prototype. Basically, I think it's basically ensemble. It's not a couple model prototype. It's just one member. It's all we call it deterministic. It's only one member. EP means ensemble. We write 11 members with initial perturbation. Initial conditions are different from each member, and also we have models the cat physics.
Yeah. The third question is,
I'm not sure if I.
yeah, I think you may answer with the script later. Are any of output files available, and if so, where? And do you run any of the newest iteration in the further of live?
Yeah, and the output file. We do have output file available, but only on SPSI right now, and also on the NOAA disk, like Clubhouse 2, and I'm not sure if anyone from community can access SPSS right now. Probably not. I guess. Do I run any new iteration? No, we don't have. I guess this is the newest iteration, means the latest cases, like something like that. Real-time run or real-time parallel run. No, we don't have that.
Okay.
But we do have. We're gonna run the retrospective for Capsule 13 before the implementation. We're planning this 2.5 years. But still, it's not real time. Sorry, but it will be for the very recent years, like 2022, 2023. But we are not going to run the real time like GFS usually have real time parallel run, but we don't for Ensemble.
Right, sounds good.
And
yeah,
we have this one.
Seasonal to sub-seasonal application.
Yes. No, we don't have updates for that, but I think within EMC and also the outside EMC, after we have all this output data available, some other center will do the evaluation for atmosphere river or syndrome source. We are going to use our data to do the evaluation, but not within EMC. But I just think CPC is going to do some draws evaluation, or had done that before for previous Ensemble prototypes.
Okay, I think your written answers to the document would be helpful to foster.
Okay. Yeah. Later, I'm gonna input. Yeah.
Sure. Okay. A sincere thank you to our esteemed speakers today for their valuable insights. Remember, speakers will continue to engage with the discussion document post-webinar, so please feel free to add your questions or comments for further discourse. Both presentation and recordings will be archived on the NOAA Week 3 S2S website, accessible through the link provided in the chat box. Okay, thank you very much, and let's meet again on July 1st at 2 p.m. EDT. Thank you, everyone.
Thank you.